Section 1.6, solving equations. Finally, we're going to actually be able to solve something here. So, bottom line in this section is we're going to be given an equation, and we're going to look at different routes to take, different methods to use to ultimately isolate the variable. And usually that variable is x. Okay, what is that? Well, it's just a letter that represents a real number. And so we're going to be solving for those real numbers here in just a minute. You can put them in set builder or solution set notation if you like. You don't have to. What this would mean would be, let's say the answer is 2. Okay. Well, you could simply just say x equals 2, or WebAssign, just enter the number 2, and in the rectangular box like this. In WebAssign, you just put a 2 in there and then click submit or next question. But really, you could use set notation. A real simple way to do that would just be x is a member of the set containing the element 2. But we're not doing paper tests, probably. We're just going to use WebAssign throughout the entire semester. So anyway, you don't need to worry about this. Just know how to solve for the variable, okay? And we're going to use properties of real numbers to do that. So here are some equality properties of real numbers. I'm sure you've seen these before if you've taken Algebra 1. You know the addition property of equality. If you add something to one side, you'd better add the same thing to the other side. All right, just like if you're doing reps, like bicep curls or something, you want to do, maybe 50 pounds, 10 reps on the left arm. You better do the same thing, 50 pounds, with your right arm as well. Otherwise, you're going to look kind of silly. Okay, so what about A equals B? Well, you can multiply the same thing by each side, it's still equal, okay? So just remember, what you do to one side, you do the exact same thing to the other side, all right? We're going to be looking at in section 1.6, linear equations, all right? These are the most basic types. They're linear equations because the equation is of degree 1, all right? Which means you're going to just have an x, or x to the first understood. All right, we'll get into quadratic equations a little bit later in the course, okay? So let's start off with one of the most complicated examples here that I think you're going to see in the entire class. And I'm referring to example number 1. As you can see, extremely challenging, all right? There's no way you could just look at this and guess what times 2 plus 5 equals 11, all right? Well, let's see, that'd be 3. Okay, but whatever. I'm kidding, of course. So how do we solve this thing? The first thing you want to do is get rid of the addition and or subtraction that is occurring, okay, within the algebraic expression. And that is, of course, if there are no grouping symbols. If there are grouping symbols or fractions or things like that, you may want to do something else first. But we'll talk about that when we get to it. So anyway, we subtract 5 from both sides. It's going to leave us with 2x equals 6. And at this point, we can divide both sides by 2, which is, of course, the same as multiplying both sides by 1/2. And you get your solution. So x is 3. And you leave it just like that, all right? You leave it just like this for your work when you have to submit your work for me on any one of the tests or the final exam, okay? You don't need to use set notation or set builder notation. You don't need to define x as being a member of the set of all real numbers. Nothing fancy. This is fine, okay? Well, let's move on to example number 2. So in example number 2, you now have fractions involved. This one isn't too bad. It's not too bad because you could distribute this 3/5 through this quantity and get 3/5 x plus 3/5. And then on the right, you could do the same thing. 1/4 times 2x would be 1/2 x. And then 1/4 times 4 would be 1. And then you can go on from there to solve for x. But what I'm going to do is go ahead and show you how to get rid of these fractions in case you do not like fractions. All right, so this is example number 2. I'm going to get rid of this because we already know it's example number 2. And what I'm going to do now is I'm going to add 2 pairs of grouping symbols there, 2 pairs of parentheses. And I'm going to get rid of these denominators, okay, within these 2 fractions. And I'm going to do that by coming up with, guess what? The LCD, okay, the least common denominator. So what's the least common denominator with respect to 5 and 4? Well, it's actually 5 times 4, which is 20. So I'm going to multiply both sides of this equation by 20. And watch what happens when I do that. So this on the left-hand side means 20 times 3/5 times x plus 1. Okay? So let's just do 20 times 3/5. 20 times 3/5 would be what? 20 times 3/5. This would reduce to a 4, and you would get 4 times 3, which would be 12. I'm going to write that down. Note the x plus 1 quantity stays the same. All right, on the right-hand side. Again, just look at the numerical parts. We have 1/4 times 20. All right, obviously it's 1/4 times this quantity times 20, but I just want you to home in on the 1/4 and the 20. Okay, so what is 1/4 times 20? Well, it's 5. So you put your 5 down there, bring down the quantity 2x plus 4, and now you're ready to rock and roll. All right. At this point, let's go ahead and distribute on both sides. So on the left-hand side, you get 12x plus 12. On the right-hand side, distributing the 5 through, you get 10x plus 20. And now you need to get the variable x on one side of the equal sign. Okay, so I'm going to do this. And I tell you what, I'm going to go ahead and also, since I know now, I'm going to have my x term on the left. I'm going to move any constant term from the left to the right. So I'm going to subtract 12 from both sides as well. And when I do that, note this is gone and this is gone. All right? So what am I doing? I'm trying to accomplish a goal. What is that goal? I'm trying to get the x term isolated on one side of the equal sign, and then I'm trying to get the constant isolated on the other. So I get this, which is, of course, going to give me 4 if you divide both sides by 2. Finished with the second example. The third example. This one's a little more complicated because you have the sum or difference here of 2 rational expressions set equal to another one, and you have different denominators everywhere. Okay. Well, the best plan of action here would probably be to come up with the LCD of the whole thing. Now, you may have been taught how to do this differently, and that's fine. In other words, you might just want to come up with the LCD here on the left, which is 12, and then simplify that first. Then come up with the LCD of the whole thing. Then, solve the equation accordingly. But how I'm going to show this is number 3. I'm going to get rid of this. How I'm going to show this is by just doing it in one step in terms of the LCD. I'm going to eliminate all my fractions in one move, okay? So we have to come up with the LCD then, if I'm doing it that way, with respect to 3, 4, and 10. All right, so what is the LCD with respect to 3, 4, and 10? Well, one way to do that is to write down the fact that 3 is the same as 3 to the first. 4 is the same as what? 2 squared. I'm coming up with the prime factorization of these numbers, these 3 denominators. 10 is the same as 2 to the first times 5 to the first, right? So how do we use this information to come up with the LCD? Well, remember what we talked about a couple sections ago, all right, back in section 1.4. The LCD is going to be the product of all the prime factors of highest power. So the LCD is going to be equal to 3 to the first times what? The product of all the prime factors of highest power. Well, here you have a 2 to the second, and here you have a 2 to the first. Well, the base we're going to use is 2, and of the highest power, so it's got to be 2 squared, okay? Because 2, of course, is greater than 1. And then we also have a prime factor 5 to the first. So the LCD is going to be the product here of these 3 numerical values. So 3 times 4 is 12. This is 4. 3 times 4 is 12. 12 times 5 is, that's right, 60. So 60 is our LCD. Okay, so what am I going to do with this LCD? Well, I'm going to multiply both sides of this equation by 60. And so let's take it step by step, expression by expression. All right, so what I mean by that is, let's just look at this first. All right. What do we get when we have 60 times 2x minus 1 all over 3? Well, 60 over 3 reduces to what? 60 over 3 reduces to 20, and then I bring down the 2x minus 1. Okay, bring down your plus right here. All right, the next thing. What's 60 divided by 4? What's 60 divided by 4? Well, that's 15. So you write 15, and then bring down the quantity of 3x plus 4. All right. Now, the right-hand side. The right-hand side, you got 60 divided by 10. 60 divided by 10, which is just going to be 6, right? And then you have this being multiplied by a 7. So don't forget about the 7, okay? So this is going to end up being 6 times 7, which we know is 42. And again, bring down the x plus 3. Okay. Again, I'm not trying to make this more complicated than it has to be. I'm just showing you a technique that will allow you to clear out all your fractions if you want to do it all at the same time. And it's based on the concept of LCD. Okay, so at this point, notice all our fractions are gone. Let's rock and roll here. We're going to distribute 3 times. We're going to distribute 3 times. So here we go. 20 times 2x, that's 40x. 20 times negative 1, that's negative 20. 15 times 3x, that's 45x. 15 times plus 4, that's plus 60. And now on the right-hand side, we have 42 times x. That is 42x. And then we have 42 times 3. 42 times 3. Again, you're allowed to use your calculator. That's plus 126. All right. At this time, if there's anything you can combine on each side, go ahead and do that. So we have like terms here. We have a 40x plus 45x. That's the same as 85x. We also have negative 20 plus 60. Those two constant terms are called like terms. Negative 20 plus 60 is plus 40. And I'm going to go ahead and bring down the entire right-hand side. Nothing more you can do there. Okay, at this time, we're going to do the exact same thing we just did in the previous example, number 2. So we're going to subtract 42x from both sides so that our x terms are on just one side of the equal sign. And I'm also going to subtract 40 from both sides so that my constant term is just on one side of the equal sign. So let's go ahead and do that. 85 minus 42x. What is that? 85 minus 42 is 43. So we get 43x. And that's going to be equal to what? What's 126 minus 40? This difference is 86. At this point, you would divide both sides by 43, leaving you with x equal to 2. That's right. X equal to 2. Finished with example number 3. I hope you're having fun.